Okay, so here's some numbers that we're going to use to do a cubic regressions. Type them into your graphing calculator under the stat button, and I'll pause while you do that. Okay, so now I'm going to use the stat button once I've got the numbers in this edit area. Okay, now I'm going to go to the stat. I'm going to do calculate, cube reg, which is number 6. And this is really an important part. I strongly encourage you to put in the L1, comma, L2, comma, Y1 is under the vars. Oh, not second. Vars, Y vars, enter, enter. There we go. When I hit enter, it tells me my data, or my equation here. Your numbers must be different if you got different on your calculator. So I'll move this over so you can see. What if I move all of this data? There. Okay. So now, what can I do with this? I go to the table, and my table is at 1, 2, 3, 4, 5, 6, 7, 8, so that's all good. So what if they told me that the time was year 10? Well, you just keep going down until you find where the time, or the x, is 10. Okay, so it'll be 820. The numbers were going up pretty fast, so that makes some sense. What if they needed 4.3? Mine doesn't count by 0.3s. How do I make it count by 0.3s? Table settings. Second, table set. And I have my table starting on 4 right now. I'm going to have it start on 1. And then I'm going to have it count by not ones, 0.1s. And then I hit table. And now my table counts by 0.1s. So if I wanted like 1.5, then I know the answer would be 2.9. All right. Any questions about how to do these? Yes. Yeah, absolutely. Yep. Okay. I don't know if the table is counting by ones, what would happen? Never tried that. Let me go back to table settings. She was asking, what if I set my table start to like 4.7? And then I have it, what if I have it counting by ones though? And I hit table. Ah, it starts at 4.7, goes up by ones from there. That makes sense. Yep, it does. Okay. All right. Any questions about cube reg? All right. This is one of those things that you could actually use in the real world. You could take data, any kind you want, and if you think it's quadratic kind of data, you can do a quadratic regression, get an equation. They do this for instance, bones, measuring on bones. They figure out at a person that's 6 foot tall, the length of their leg bone is a very consistent thing with their height. So in other words, if let's keep it really simple. Let's say a 6 foot tall person has a 2 foot long, what's that big bone called? Femur. Okay, let's say it's 6 foot goes with 2 foot. Okay, well then you could say a 3 foot tall person would have a femur that is exactly half of that, right? 1 foot long. And so they can measure the length of a femur bone and say, I can tell, even from just this one bone, that this person was this tall. They have charts like that. How do they get those charts? From doing a regression. Okay? And it's a linear regression on a human being. So you can find just at one bone, and even without DNA and everything, just measuring the bones, you can tell a ton. All right, enough of that. Let's move on to what we're going to be tested on here. Next kind of stuff is you're going to have your test tomorrow on graphing. What if I said to graph this? Well, there's graphing and there's sketching, and they're two different things. Sketching, all we care about is a few of the points. Graphing means you got to get all the points right. Just sketch this one. Just a rough sketch. And a rough sketch would include the vertical and the horizontal asymptotes and just generally what it looks like. I'm going to pause while you try that. All right, so here's what you should have been thinking. Verticals, those are like x equals things. Horizontals, those are like y equals things. And the x equals stuff, what would crash this? 4, so it's that. The y, Bob will tell you why. Remember the new thing I told you about Bob? Is that he's an outsider. But there's nothing outside this, so then he's a 0. And if I were going to sketch this, I would start with those. Wait a minute, I should probably start with the axes. And then y equals 0. This is a spot where y equals 0. And this is another spot where y equals 0, etc. So that's that one. And then the one that's x equals 4, this is a spot where x is 0. Or 4, sorry. And then whether the spot where x is 4, that's this one. So there's my asymptote lines. I'm gonna go back and make them both dotted lines. Okay, so there's a dotted line this way, there's a dotted line that way. And now if you know what the parent looks like, the 1 over x parent looks kind of like that. Then you know that this one looks like this. Now what if you wanted to check yourself? Remember how I said the XY chart is very handy. You go to the back to the XY chart and say, okay, pick a number. Well, I don't want to pick a number that's really hard. I want to pick a number that's easy. So I'm going to put in like 5 there. Okay, if I put in a 5 for x, then I'll have 1 over 5 minus 4 is 1. 1 over 1 is 1. 5 comma 1. Over 4 up, over 5 up 1. There I am. I'm on the graph. See, I can check and make sure it's in the right spot. It's really smart. You should do that. All right, you make a little XY chart for them. All right, this one. What could you tell me about this guy's graph? You could not tell me all the details unless you had a graphing calculator, which you won't. So what could you tell me? Y-intercept, good. The Y-intercept is where x is 0. So that would be 0 and that would be 0. So these are canceled. And what's the Y-intercept? -7. So you know it touches it, -7. Okay, tell me something else you know. It's going down on which end? Well, to start with, it's going down on the right because of that negative in front. And then since it's even, they have to go together. They're either both up or both down. So it must be both down. So now this is where you can be creative. It can do whatever you want between these two, as long as it has degree 2. So in other words, I could have a bounce, and then it could cut through, or not cut through, but it could touch that Y-intercept as long as it's going down on the right. See, it had a bounce. That's degree 2. Could I do this? No, because that would be like degree what? Degree 4. Because see, 1, 2, 3, 4 cut throughs. So that's not good. Could it cut through and then bounce and then cut through again? No, because that'd be degree 4 also. So that's not really an option. Could it cut through twice? Yes, it could. All right. So there's options, but there's not like unlimited options. All right. Any questions about how to do that kind? That kind's different than this kind because this kind you know what's happening, whether it's bounces or cut throughs or snakes. Remember those 3 words. When they ask what is the behavior, it's either a bounce or a cut through or a snake. Cut throughs are single roots. Stay with me. Try this one. Graph it. I'd always start with how the story ends. On the right, is it going down or up? Down. And then I would be thinking about, okay, got to touch in a couple spots. It touches at 3, touches at -5. And what does it do at the 3? It bounces. So I know it has to be doing that. That makes me think about the Y-intercept. Y-intercept is where x is 0. If I go back and put in a 0 and a 0, I get -3 squared is 9, and then I make that negative. It would be -9 times 5 would be -45. So you're way down here somewhere. Like a touch. The Y-intercept. And then as it's coming back, is it going to cut through at the 5 or is it going to bounce? Cut through. So it's just cut through. Like that. You missed it, but that will say that. What if I just move the black thing over there? There, I'll just do that. I'm cheating, but that's okay. And now I've got a degree. Wait a minute, this is degree 3, and I only see a 2 up there. Is this really supposed to be an even one or an odd one? It's an odd one because you add these up on this kind. On a factoring kind, you add them up. On the other kind, you pick the biggest one. When they're like it. When they're written like this, if I had multiplied this all out and it came out to negative x to the third, minus 2x squared plus 15 or something, then that kind you pick the biggest one and you say that's the degree. But if it's factored out like this, it hasn't been multiplied out yet. So you have to add those two together to get your degree. Okay, that's how that one would look. Let's move on. Here's another one. Do you remember what the parent one is on this one? 1 over x squared. And what is 1 over x squared on this? Do you remember what that kind of looks like? To me, it kind of looks like a volcano. So then graph what this one would look like. It's been moved, it's been stretched, it's been flipped. Maybe it hasn't been stretched. It's at least been moved and flipped. I'll get you some. I'll get you some. Kleenex in there. All right, here's what I would have hoped you would have done. Hoped you would have thought, okay, I'm going to start on the inside. That means move to the right 3. The whole thing moves over to the right 3. So now it kind of looks like this. And then what about that? What does that do? Flip it. Up, down, or left, right? Up, down. So then I'm going to get rid of these guys, flip them up, down. There. And then it'll look kind of like that. And there's an asymptote running down here, which is why it does that. And there's an asymptote running like this, too. Raise your hand if you would have got that one right. Okay, good. Now, what if your grade depended on it? How could you check it? XY chart. An XY chart. Just pick any number you want, I suppose, but it'd probably be smart to pick numbers that are going to work nice. So you just kind of look at this and say, well, I don't want to pick like 4.3. I could pick like 4, because then 4 minus 3 would be 1. So I'm going to pick x is 4, 4 minus 3 is 1, 1 squared is 1, and it's negative 1 over 1, which means negative 1. So 4 should go with negative 1. Over 4, down 1. Look at that. There's a spot right on my graph. It looks like I'm doing it right. If your spot had come out like here, you'd be like, uh-oh, I did something wrong. So it's a way to check yourself. All right, move on. This is the kind of graphing question where you have to take the limits that I give you, and you make the right picture for it. Start with the asymptote lines. Actually, start with the XY axis. Figure out where the asymptote line would be, and then just do your best to sketch it. I'm going to pause while you work on it. All right, here we go. So we're going to start with an asymptote line. I can tell that it's getting closer and closer to 7. And whenever it does this plus and minus kind of a thingy here, it means that it's coming from the left or from the right. So 7 is like here. And as it gets closer and closer to the 7 from the left, that would be from the negatives. That's this one right here. It would be hitting infinity, so that it has to be going up to infinity. All right, this one also, from the right, it also goes to infinity, so it looks kind of like that. There we go. There's your answer. Now, how do I know what it's getting close to on the other end? Oh, wait a minute. The other end's got to be getting close to negative 4. That's the other asymptote down here. So then I really should clean this up a little bit and make it, I'm going to give my answer in blue. It should go up to infinity, but it should get closer and closer to that. And then also up to infinity here, and then closer and closer to that. All right? Any questions on that part? All right, then. All right, so here's one where I've got my limits written, but I haven't finished them. This is the other kind of test. This is called communications. Because it's got the graph already. It's not about graphing it. It's about telling me about the graph in terms of limits. So they might say something like, tell me about the limits on all 4 places. There's way to the right, way to the left. And then as you get close to the middle, you can come from the left or from the right. Why don't you write me all 4 limits for this function? So how do you go way to the right? What does x approach? Right. So everybody make one where x approaches infinity. Now go way to the right. Alright, so I'm going to do that one here. If x approaches infinity, I go way to the right. I go way to the right over here. What's it get closer and closer to? It's this line right here. It's closer and closer to 3. So it's 3. Okay, on the left end, I'd be getting way, way over here. It's going to also get closer and closer to 3. So if I change this to negative infinity, it would also be 3. Then the other ones are ones where they get close to 4, or negative 4, sorry, right there. They get close to this line right here. And that's negative 4. And you could go from the right, which would be the positives, and that'd be from over here. And then I'd ride in on this line right here, and it would force me up to positive infinity. And then the limit the other way, as x approaches negative 4 from the negatives, that's from over here somewhere, I'd ride on this line, and it would force me to negative. All it takes is to be off by a negative, and you're wrong on the whole answer. Because obviously negative infinity and positive infinity are totally different things. So you be careful. How many of you think you would have got all 4 parts right? Awesome. Excuse me. Okay. There is a picture. What is the equation? Starts with y equals. You should know a lot from the picture. I'm going to pause for a second while I finish that one. Okay, some thoughts? You know anything? It's negative. Why is it negative? There's a simple answer why it's negative. One down on the right. No, I misunderstood what you said. Okay, we're good so far. Now what? X plus 4, and then it's squared. Why is that squared? The bounces there. Keep going. Oh, by the way, the squared is called multiplicity. That is, you didn't say anything wrong. It's just when we get to the next part that we're going to ask you about what's the multiplicity. That's the little number that it's brought to. And the fact that it's bouncing, that's called its behavior. Okay, how about the 3? What should you put for that? Good. Was that single or double or triple? Single. So I can put a single or I can leave it alone. And then is that cutting through, bouncing, or snaking? Cutting through. All right. And is that cutting through or snaking? Okay, cutting through. So there's a multiplicity of 1. The total multiplicity is called the degree. The degree of this thing would be what? 2 plus 1 plus 1 makes degree 4. If I wanted to know that just from looking at my equation, I'd look back and see that squared times that times that, x to the first times x to the first times x to the second times that negative in front, it's negative x to the 4th. All right. So I would have known that it was negative, therefore going down the right. I would have known that it was degree 4 from there. All right. So here's that little chart kind where you'd have to tell me what's the root, what's its multiplicity, and what's its behavior at that place. Question? On the last. Yep. Ah, is it a snake or not? That would be a good question. And if you're not able to tell on, I didn't intend it to be, I just intended it to be a cut through. So how can you tell when they intend it or when they don't? It's hard to tell. And I get you. There, that kind of looks like it could be changing rates there. But if what you're really looking for there is one that kind of replicates x cubed, okay, where it kind of, I didn't draw that even that awesome. I'm going to try again. Okay, this one didn't, this part of it right here isn't looking right to me. To be an x cubed or a snake, this part right here has to be kind of curved the way it's curved. You know what I'm saying? It'll be more obvious. And if you're not sure, if you say, can I ask if this one is snaking through here, I'll be able to tell you that. You know. All right. Yep. Moving on to this one. Tell me what the roots are. Tell me what the multiplicity is at that root. And then what's that called? Snakes bounce cut. And simplify them to about 3 words. Snakes are bouncers. All right, so hopefully you said that the first root was 4. Notice I don't use negative 4. X minus 4 has to equal 0, x equals 4. See, you set this equal to 0, then what comes out is your answer. All right, so we got 4. And what kind of root is that? Single root, multiplicity 1. Behavior, cut through. And the next one's a 7. You're looking 7. Try again. Negative 7. That was even wrong. There we go. Negative 7, and the multiplicity of that one is a 2. And what kind is that? Bounce. All right. We've learned a lot about polynomials. Any other things that you guys have questions about? All right. I didn't cover every possible thing on the test. I covered a lot of it. And what is a bigger list? All those problems that I gave you for homework. Okay, if you've already finished them, the ones I gave you on Friday, then cool. But then you have nothing to do for tonight. Almost makes it a little harder because you got to figure out what to do to study. Don't just sit there at home. This is 2 tests, 100 points each. Okay, this is going to affect your grade a fair amount. Tomorrow and the next day. Answers for this worksheet will be posted. Yes, yes. Extrema, that just means the high and low points in the graph. We haven't stressed it very much, but what are the extremes of this? That, and that. That's all you have to know. That's it. Calculator, say that again. If you were going to find the extremes, you could do that deal where you find the minimum and maximum. It's under second calculate, but I'm not worried about that for you on this test. But in general, if you have a graph, let me just change my graph to y equals 5x just to make it simple. Let's clear the rest of it. And I hit enter, and I hit, oh wait, that's not going to have a high spot. Change that to, oh, it's always more complicated. Negative 5x squared. That's not squared. Squared. There. Now if I hit graph, how can I find the high spot in that graph? Well, that one's pretty easy. It's at 0. But I could do second calculate the 0. That's number 2. And it wants me to be on the left side of it. So I move the little spider around until I'm on the left side of it. There, I'm to the left of it. I hit enter, and then I get to the right of it. And then I hit enter. And it brings up these 2 little things right here. You see those? That tells you you're between there and there. And then you got to get on top of that spot and then hit enter. And it tells me that it is actually at, oh, I had a flaw in mine. I think I had the minus sign, not the negative sign. So anyway, that's how you do it. I don't think you're going to have